Alright, good morning, ladies and gentlemen. We're going to be looking at word problems today involving Pythagorean relationship. So what's really cool is that the Pythagorean relationship so far, as we've looked at it, is only really applied to just pictures of triangles, which really it's great that we can predict what each side of a right triangle is going to be if we're given the other two sides. But why do you care? Because when are you going to look at just triangles in real life, or what's the practical application? And a lot of the times in math, we sort of force the practical application, but what's really cool about Pythagorean theory is that the application is very, very real. Because what Pythagorean lets us do is figure out distances or measurements that we normally couldn't measure ourselves or would be incredibly difficult to measure. So Pythagorean is actually used a lot of the times in GPS and tracking and telemetry and a lot of just distance measuring, used a lot in construction for this purpose, used a lot in geocaching, geophysics, all kind of cool things where people are trying to find out how deep certain things are or how long things are based on the fact that we know two sides of a right triangle, which is really, really cool when you think about it. So it gives us a lot of predictive power. So the kinds of word problems we're going to look at today, there's two, maybe three major types of word problems. The first two that we're going to look at today involve us finding a distance between two things that we don't normally know, or how long something is given the other two lengths. And the other major way of looking at word problems is looking at proving whether or not something is a right triangle or is not a right triangle. Alright, so we're going to look at this first problem here. And this is when we're trying to find an unknown length. So it says that the base of a ladder is 3 meters from the wall it is leaning against. If the ladder itself is 10 meters long, how high on the wall does the ladder reach? There's really one good strategy to solving these types of problems, and it's the most important possible thing you can do, is to draw the triangle that it's describing to you. Alright? And so to do that, you kind of need to figure out what's the base of this triangle, what in the word problem is the height of the triangle, and what in the word problem is the hypotenuse of the triangle. So if I'm looking at my problem here, this one's nice because it tells me that the base, I don't know why it's a laser pointer, although it is May the 4th on the day that I'm filming this, so it is Star Wars Day, so May the 4th be with you. Anyway, back to this. So it says the base of the ladder is 3 meters from the wall it is leaning against. So what that means is, if I'm going to draw my picture, we'll say this is 3 meters, and it's leaning. This will be my wall here, my beautifully drawn wall, and then we'll have our ladder reaching it. So now I have a right triangle, which is great. The question now is, where do I put this 10 meters? Alright, so it says the ladder itself is 10 meters long. So it says the ladder is 10 meters long, and then how high on the wall does it reach? So this has to be our wall here, which means that the ladder here is 10 meters. Alright, and that's going to be the hypotenuse of our triangle. So going back to what we talked about last week, the Pythagorean relationship, as you all should know by now, is a squared plus b squared equals c squared. Alright, we know our a, we don't know b, and we know our c. Alright, so I'm going to go 3 squared plus b squared equals 10 squared. Sorry guys, it is hard to write on this iPad. I will get used to it eventually. Alright, 3 squared is 9 plus b squared, which we still don't know, equals 10 squared is 100. Alright, now we want b on its own, so we're going to subtract 9 from this side. Whoops. 9 from that side, and 9 from that side. Those 9s are going to cancel out, and I end up with b squared equals 91. Now, just like we did back in the algebra unit, all I have to do is find the square root of both sides. So I'm going to draw a little square root sign. And I'm just going to do this next part on my calculator. You'll have to trust that I am doing this. So square root of 91 is, hopefully you can hear me hitting buttons so you know, is 9.5 approximately. So B is approximately 9.5 meters. So the ladder reaches 9.5 meters up the wall. Okay, so nothing too tricky. We're still applying the same theory. It's just a matter of, what I find with these problems is drawing this picture, or figuring out how the right triangle is supposed to look, is kind of the key. You know that you've done something wrong is if, when you draw your picture, it's not a right triangle. And so I'm going to tell you that this picture is so important to solving these questions that in terms of showing your work in a problem, you absolutely must draw a picture of what's going on. Notice I didn't draw any fancy rungs on the ladder or a fancy wall. I just drew a right triangle, but I labeled the three sides. And you don't have to normally say A, B, and C. I just did that to show you guys. But it might be helpful for those of you who need to see things visually. Alright, let's look at the next type of problem that we can do. Alright, this one is, I think, the more common style that you're going to see, and this is where you can start to see where Pythagorean is actually really, really useful. So it says a boat leaves the dock and travels 20 kilometers east, and then turns and goes 60 kilometers south. How far from the dock is the boat? So to draw my picture for this, the first thing I'm going to do is this 20 kilometers east. Alright, so I'm going to draw a line going east 20 kilometers. Alright, and then the problem says at that point, actually sorry, let me just put a little dot in showing where we started from. I'll actually use a little star because I'm very fancy. So this is our starting spot there, that star. And we went 20 kilometers east from there. And then at that point, so it says, and then turns and goes 60 kilometers south. So now I'm going to draw a line going straight down 60 kilometers. Okay, so right now the boat has gone 80 kilometers altogether. It went 20 kilometers this way, and 60 kilometers this way. And then it says how far away from the dock is the boat. So what the question's asking is not how far has the boat traveled, otherwise you'd just be adding 20 and 60, and let's be honest, that's not grade 8 math. So instead what it wants to know is what's the distance from the boat here to the dock here, which as you see forms a nice hypotenuse to the triangle that we already have. So you see I now have my right triangle. You can kind of ignore the star, I'm just doing that to show you where the original dock was. Alright, so now this goes back to our easy a squared plus b squared equals c squared type of equation. Alright, this time we're trying to find the hypotenuse, so we know our a, we know our b, we don't know c. So this one's nice because we just follow the straightforward formula. So it's going to be 20 squared plus 60 squared equals c squared. Alright, 20 squared is 400. Sorry. 60 squared is 3,600. Alright. And then all we have to do now is add those two together. So 3,600 plus 400 is 4,000. So 4,000 equals c squared. Now we take the square roots of both sides. The square root of 4,000 should be 63.2 kilometers. So I just did that last part on my calculator. Alright, so the boat is now 63.2 kilometers away from its starting location at the dock. So this is where I say that Pythagorean is actually very useful, because a lot of the time navigators or people out at sea will use Pythagorean theory to figure out how far they are from the original location based on how they've traveled in terms of east, west, north, south. So you can hope see the practical application of Pythagorean there. Alright, I have one more example problem to show you guys, and then we can move on to some work. So this last one has us looking at proving that something is a right triangle or not. So it says, Mr. Barry was told that he was getting a 60-inch television for his classroom, which, by the way, we will, and hopefully not while I'm in Quebec. But when it arrived, he doubted that it was really that big. The television was 40 inches wide and 30 inches tall. Could it possibly have a diagonal distance of 60 inches? So I don't know if you guys know this, but when they say that, you know, a TV is 60 inches, what that means is the distance from here to here. All right. So if you measured that line, it would be a 60-inch line. All right. And so the length and the width of the TV are going to be a little bit different than that. But why won't it undo now? I just have a giant cross in the middle of my line. Well, let's just erase that. Anyway, perfect. So this time we're trying to prove that a TV with a side length of this and a side length of this, would it or would not have a diagonal distance of that. So if I'm going to draw my picture here, this is how we're going to draw a square, or a rectangle, I suppose. Alright, and I said it's 40 inches wide and 30 inches tall. And then based on what the people who brought the TV said, it should have a diagonal distance of 60. Okay, if that's correct. And so we can prove whether or not that's correct by seeing if a squared plus b squared equals c squared. Because now you see I have a triangle that's 40 inches long, 30 inches tall, and has a hypotenuse of 60. So we're going to just test that out. It should be nice and simple. Alright, all we need to do is see if 40 squared plus 30 squared equals 60 squared. So I'm going to do this in 2 steps. So 30 squared plus 40 squared. Alright. 30 squared is 900. 16 squared, or 40 squared is 1600. Alright, and I just knew that because, well, you could do it in your calculator, but you know that 4 times 4 is 16, and now you just add the 2 extra zeros in there. Alright. Anyway, 900 plus 1600 is 2500. Okay. Now, what we're going to do is see what 60 squared is. 60, as we just looked at in the last problem, 60 squared, or 60 times 60 is just 3,600. And as we all know, 2,500 does not equal 3,600. So no, this is not, this is a 50-inch TV instead of a 60-inch TV. So this is not a 60-inch TV. Shame on you. Alright. So again, all we're doing is looking at Pythagorean and just proving to see whether this triangle fits Pythagorean or not. Alright. If you have any questions, please feel free to ask Mr. Courtney. And there are some textbook problems for you guys to do. I hope you're having a wonderful week without me. And I miss all of you very, very much. Thank you.